Questions number 17 through 24, solving absolute value equations and checking with our graphing utility. Now, the graphing utility could be graphing by hand or graphing using Desmos. So I'm only going to do a few here on the video, and then the rest of the key will be available online just to talk through the three different options that we have. I'm going to start off with question number 19, and we're going to start by looking at this equation in terms of the graph. What does it mean for absolute value of 3x plus 1 minus 5 to be equal to negative 3 in a graphing standpoint? So we're going to set each of these as y equals in our graphing utility, either by hand or Desmos. Here we're going to go ahead and set it up via Desmos. Y equals 3x plus 1 minus 5. We get an absolute value function. And y equals negative 3. This is a Hoivux, a horizontal line here at negative 3. Now, what does it mean for it to be equal? That means where does the graph intersect? Desmos, pretty great in terms of giving us values. We simply click on the graph and it gives us our x values. We see it intersects at x equals negative 1 and x equals 0.3333. Once we get the algebra, we'll be able to figure out the decimal for that. However, we actually know it to be 1 divided by 3. It gives me the same decimal value as our intersection point, so we know it's going to be 1/3. Well, getting the graph is great. How does the algebra work out as well? Let's go ahead and start off what our steps are to solve an absolute value. We always want to start off by isolating the absolute value bars first. So looking at our equation, if we go ahead and get rid of the graphing idea, we're going to go ahead and add 5 to both sides, and then we have our absolute value bars isolated. Next, in terms of a process, we want to think about the relationship between absolute value and negatives. Here it's equal to a positive 2, so there is no worry about absolute value and negatives. So we're going to move on to the next step, which is basically applying the definition in terms of a split. Think back to if I told you where the absolute value is equal to 10, we know it's equal to positive 10, and we also know it's equal to negative 10. We're making the right side negative. So looking at this, we're going to go ahead and do our split. In us case 1 where 3x plus 1 is just equal to positive 2 like it was originally. However, now we're also going to set it equal to negative 2. In this case, we've made the opposite side negative. Now from here, we're going to go ahead and solve both equations and check against our graph, giving us x equals 1/3 and x equals negative 1. Hey, that's exactly what we got in terms of our graph. X equals negative 1 and x equals 1/3. What we see graphically should match up what we're getting algebraically. So there is our solution, in this case, 2 solutions here. Next, let's take a look at number 21. X plus 20 is equal to negative 10. Looking at this from a graphical standpoint, we set y1 equal to absolute value of x plus 20 and y2 equals to negative 10. Here we have it in Desmos. We can't actually see it yet, so remember we maybe have to zoom in or zoom out. There's my graph. Here is y equals absolute value of x plus 20, and here is y equals negative 10. What does it mean to be equal is where do they intersect? Well, even if we keep zooming out and zooming out and zooming out, these graphs are never going to intersect. There is definitely a gap in between them. So in this case, they never intersect. So graphically, we know the answer is no solution. Well, what does that look like in terms of algebra? Well, once again, thinking about our steps, we want to isolate the absolute value bars. In this case, they already are isolated. And now we need to think about the idea of absolute value in terms of negative values if it's equal to a negative number. Hey, in this case it is. Well, the absolute value cannot equal a negative number. It absolutely can never equal a negative number. So, in this particular case, our absolute value will never equal negative 10, so our answer is going to be no solution. We see it from our graph. They're never going to intersect. We see it from the algebra. Now, we must state this in terms of an answer. We can't just leave a bunch of blank space and say, oh, no solution. We must go ahead and provide our reasoning here. Just by simply writing absolute value cannot equal negative number is enough. Make sure we're going ahead and doing that. All right, last, we're going to talk through question number 22. Now, why are we choosing this one? Well, right off the bat, we notice that there is a variable both inside the absolute value bars and set equal to it. So this is a warning. There's a potential for an extraneous solution. So let's take a look at what this looks like graphing absolute value of 2x plus 12 and 4x as y equals y equals. We see that we have a absolute value function and we have a linear function. And if we zoom out, we see that there is in fact only one intersection point, and that is at x equals 6. Okay, one intersection point. We keep zooming and zooming. It doesn't really matter. We're obviously going to see that there is just one intersection point. So when we're solving, we may get an extra answer. We only want to keep one of them. Let's go back then and jump to our steps. We want to isolate the absolute value bars, then check for any negative value. The bars are already isolated, and we don't have any negative, just straight up negative numbers here. So we're going to go ahead and do the split. Once again, we have equal to 4x. Absolute value stuff in the absolute value bars has not changed. However, we have set equal to negative 4x on our other side. So let's go ahead and solve these. I'm going to start with the negative. Subtracting 2x, then dividing by negative 6 gives me x is equal to negative 2. Solving the positive case, we get x is equal to 6. Well, checking it graphically, we see that, there is actually only one solution. X is equal to positive 6, so x equals negative 2 does not work. It is an extraneous solution, and there we have it. So those three examples highlight the three different ways or different possibilities for solving an absolute value equation. We could get two solutions. We could get one solution down here with an extraneous, or we could get no solutions at all. The rest of the answer key is viewable online. Check those problems out.